Welcome and thank you everybody for joining us once again on our career series, where we embark on conversations aimed to uncover how to embracing technology can propel the development of professionals of the construction industry. And today we have a new guest, somebody who is very successful in the field of computational design and has been able to forge a career on their own. I'm talking about Tarang Gupta. Tarang, are you there?
Yes. Hi, Arat.
Hello,
Hello,
Tarang.
everyone. Good evening.
Nice to have you here. So let me tell
Yes.
you a little bit about Tarang himself. Let me go ahead and do this. He is a founder of 105 Technologies. He is a computational designer, specialist with over a decade of experience in providing efficient solutions to the AEC industry. With expertise in generative design, process automation, mass customization, and energy optimization, Tarang drives advancements in the intersection of technology and architecture. And he is also a lead mentor here at Novator at the Master Computational Design course. He was once a computational developer at 5C Technologies in the Netherlands, and he also is a Bachelor's of Architecture at Savitribai Phule University in Maharashtra, India. So thank you so much, Tarang, for joining us today. How are you doing?
Yes. Thank you for having me here, Arat, and also Novator. And I'm really excited to, share my learnings from my journey with all of our guests today. So, yeah.
Excellent. Thank you for being here. My name is Arad Kakis, and I'll be your host of today. So before I begin with the main agenda of this session, up until this point, you may know a little bit about our career series contest that we are running. But for the people who may be joining us for the first time, let me tell you what this is all about. So in this series exclusive contest, we are picking 3 people out of all the assistants that are joining us in every single session for a chance to win a one-to-one exclusive conversation with an industry expert of their choice. It doesn't matter if it's an architect, an engineer, a BIM specialist, or computational designer, you will be the one who picks who you want to talk to. And the way that we are determining who will be these top 3 people that will win the prize is via a system of points. All you have to do is attend the session, engage with it, make questions, and make sure to stay on top of the leaderboard each week. And as you can see here in the screen, each activity will gain you some amount of points. For example, attending 2 episodes grants you a certain amount of points. Asking questions, attending 45 minutes or more will grant you more questions as well. Each week, we are updating this leaderboard on our social media, so make sure to go there and check who is winning this race. So the top 3 attendees with the highest scores at the end of the series will be declared the winners. And of course, as you can see, this is a unique opportunity for you to gain insights and interact with excellent and successful professionals from the construction industry and gain some valuable insights and guidance from them. So don't miss this incredible chance and stay on top of the leaderboard as well, right? And speaking of engagement as well, during the session, we have some polls that I'm going to launch to the public so we can know more about your opinions on this topic as well. So, Tarang, we have a very busy schedule ahead of us. Should we start?
Yeah, sure.
Excellent. So, here you can see the leaderboard from up until this point. So, if you want to stay on top of these 3 places, you already know what to do, right? And I'm going to launch the first poll so I can also count with the opinion of the public. So, Tarang, let's begin with the basics, all right? I want to know, how would you define computational design?
Uh, for me, computational design is basically reimagining the entire design process with the help of computational tools and skill set, and also apply some logic-based algorithms to enhance your day-to-day design tasks and operations. And as architects, we've been always busy in the main aspect of design, which is the creation of design in itself. But computational, allows us additional possibilities. Like, we can run a lot of analysis on your design. It could be early stage analysis where, you can check if your building is going to perform well in terms of energy, daylight, or also do a lot of structural tests. You can also run different optimizations, which can help you, enhance your design aspect in terms of material, in terms of costing, or in terms of, energy savings and things like that. And another aspect which I find very amusing is the automation part, because as a designer, we don't really realize this, or as an architect, but there are a lot of repetitive process in our entire, start, let's say from concept stage until the execution stage, which we kind of redo every time we have a new project or we have, let's say, some revisions in the drawing going on. So I think with the help of computation, we can, automate all such repetitive tasks that we have. So in all, including creation, analysis, automation, optimization, you get a vast variety of tools under this computational design term.
Great. Thank you for sharing that with us. And now, of course, we know that there's a lot of information out there in the internet that talks about computational design and parametric design, generative design. So for somebody who might be just getting acquainted with the term and the topic itself, are they different or are they the same thing? Are they the same, like disciplines under the same branch? Can you tell us the difference between these three things: computational design, parametric design, and generative design?
Well, I think it's a very interesting question because when I was a bachelor student myself, I was also introduced to this term parametric design. And that time I used to think, it must be something very advanced that we as architects don't need. But while working in the industry, I came across these different ways of or different aspects of computational design. So I feel computational design is more like a umbrella terminology where inside it, you have these different set of aspects like parametric design or generative design. So they're not really that different from computational design, but they have their own nuances. So if I have to, let's say, start with parametric design. So parametric design is where you're creating your basic geometry models or whatever models where everything is being controlled with some slider information where you can just change some parameters and it can have an impact on how your building is going to shape up, right? So you have a lot of control over it. Whereas in generative design, you basically create some rules in the beginning. So as architects, we already are imbibed with a lot of foundational knowledge about different rules that apply. Let's say, just basic idea that a bathroom is attached to a bedroom is attached to a living room. And when you apply all these rules and create an algorithm, and you let the computer design for you, then it can generate, multiple options for us. And for me, that is generative design, where you're not really commanding the design process, but just guiding the computer with some set of rules. So that's the difference between these two design options.
Excellent. So basically, generative design is something that the computer helps us in creating different options, doing these algorithms that you mentioned. Parametric
Yeah,
design is when we control the design itself with different parameters or different information. And computational
right.
design is like more like the discipline overall, right?
Correct. So inside computational design, there are other aspects also that don't get that much of limelight because parametric design and generative design is first of all used a lot, and also you get a lot of visuals out of these two sets of tools. But there are other options where you have running a lot of simulations and analysis. I think that's also part of computational design. Then we also can do a lot of data-driven design. That is basically when you're creating any building or any geometry in your 3D models or whatever, you can actually extract all that information that can help you, do all your costings, bill of materials, and all the additional requirements that you have when you have to actually construct the building. So all those requirements can also be fulfilled by using computational design. And another thing that also would come inside computational design is where you start fabricating or constructing the actual production drawings or the site drawings, which will be released on site for the actual construction. So those drawings can also be automatically created if we use this computational workflows.
Yeah, what they call rationalizing the model, right?
Yeah, correct.
Excellent. So Now, I mean, we know that in the traditional way that architectural schools teach us, right, is in this very generalist approach, right? Like you learn a little bit about MEP, you learn a little bit about structures, about rendering, about costing, whatever. So architecture students at the end kind of become like this one-man band, right? But I mean, and of course, many people are fine with that way. I mean, I'm not judging. I'm just like making the observation, right? But
Yeah,
in this case, you really didn't follow that like a generalist or like one-man orchestra type of approach. So, could you share your journey on computational design, like including how you got first acquainted to it, and what motivated you to actually pursue computational design instead of like going this more generalist or traditional route for your career?
yeah. Uh, uh, Answering to the first question that you asked, I feel, we architects are very underrated because, the amount of knowledge that we need to acquire before we can actually go into actual designing processes is a lot. You need to know about basic building design. You need to know about the construction structures, MEP work, daylight, environmental things, material knowledge. There's so many things that an architect has to know, and that's why the demand for these specialized expertise is arising because it's very difficult for one person to have a very detailed or specific knowledge about a certain aspect. So architects become more of a generalist, and then we have these specializations who can help us in actually getting the product out. But coming to my journey, so as everyone, I think I also was very hesitant in the beginning to adopt computational design or parametric design. And I always thought, it would hamper with my creative process in terms of design. So I think I resisted for almost 3 to 4 years in my starting career. And I think my first acquaintance with it was when I was doing this project in an architecture firm in Mumbai. And we had a very ambitious design intent in this project, and the firm was looking to create a organic, this rail sort of a facade. And that time, to my knowledge, I knew the most conventional tools that were available to architects like SketchUp, CAD, Revit. And to be able to create these organic forms with these tools was creating an issue for us and was a limitation. And that's when I realized I need to upgrade my skill set. So for this particular project, I went and did like a small specialization course where I just learned the aspect of how you can actually create this particular design using computation. And I think that's when that's in fact what my understanding was of computations and how parametric design is. You can create these beautiful looking forms. But once I did the course, I actually realized it's not just limited to just creating these forms, but you can actually use the information that these tools generate to actually take advantage and automate your construction drawing processes and all the other things that come after the design process. So I think in that case it helped a lot. And as you can see at some of the pictures of this project, it was almost I think 256 brick courses, and we had these different curves happening everywhere. So it was very difficult for us to also create your different brick bonds. Some place we had the Charlie patterns, which is like a rotation of bricks at certain angles. Somewhere we had the normal English bond. Somewhere we had a different kind of a bond. So to be able to incorporate all this in that organic facade that I could create was again a big task, and that's when I again relied on computational design to automate this whole process of first generating the brick walls in Grasshopper, and then also using some additional tools to automate the entire construction drawings. So for this, I remember we had created some 256 floor plans, which were all unique. And for every brick that was turning at a different angle, we were able to color code it in a different way, which made our construction process super easy because we were not relying on some very technically strong builders. So we had to improve our game in the construction drawings itself. So in that way, we were able to adapt to any small tweaks that we had to make because of MEP cuttings and things like that. And the entire pipeline was just automated. So anytime we made a change, we had a new set of drawings available to us.
And was it difficult to like understand what was like the I guess the mindset that you needed to have in order to come up with all these solutions and all the different options? Like, was it difficult again, like from the standpoint of like the traditional architect? Did you
Yeah,
needed to like understand more about data, about like how all these shapes change, or what was the process behind this? Like, what went on there?
yeah. I remember like first when I was we were done with this entire the surface morphing. I started placing the bricks, and it was so tedious. It took me like almost 3 days. And after 3 days, we had like a design review where we changed the wall. And then I realized, that this is not feasible. So, there must be some way in which we can automate this. And I started looking into these different tool sets that are available. And in the beginning, yes, there is a bit of a learning curve where you just need to understand your geometry in terms of data. And once that thing becomes clear, I think the process is very direct. It's very straightforward. So I think as architects, we're already sound with basic mathematics and logic. So I think that helped a lot in just immediately grasping to these tools.
Excellent. Now you mentioned taking a course like a training on the like a first phase or the early steps of this project,
Yeah,
but after that you decided to actually pursue a career in computational design. Like, what was the first step that you took after this training that you took and after this experience with this project? Like, what was the next step that you took to actually chase the specialization on this field?
yeah. Yeah, I think this project was the main pivoting point in my career because after I did this automation, I never wanted to go back to creating architectural design the same conventional way. So I started exploring for different courses where I can improve these kind of skill sets. And let's say for that time I wanted to just give away with architecture and just become a specialist in creating these sort of tools. And that's when I came across this master's at U Delft, which was giving a specialization in building technology, and that course basically helped us learn about all the different specializations that we can have in this entire technology building technology term. There was computational design, structural, facade, building physics, all the disciplines were there. And then depending on your likings or your inclination, you could choose the specialization and focus on that. uh, while I was actually doing my master's, I was in fact, lucky enough to get a chance to work with different startups where, I learned of adapting these tools into the actual architectural design processes. So I was working with a startup called OMRT that time. Now it's a big company where, we were automating the entire design process of the early design understandings. So when you have to just create the basic shell firsthand and do all your analysis on that to be able to understand how your building is going to turn out. So I think that kind of helped me get a very good clarity that this could actually be a career in its own. And then I started, focusing more towards this kind of specialization rather than the traditional architecture.
Excellent. Now, when it comes to actually being like a generalist versus a specialist, of course, we know that, like we mentioned beforehand, that the generalist architects know a little bit about a lot of things, right? And sometimes this knowledge cannot be really allocated to a specific skill or cannot really be allocated to something that makes a difference, right, between a professional and professional. And with specialists, that's not the case because we can actually determine that this person is unique from the others because they know more about a certain field, about a certain skill, right? So
Yeah,
when it comes to the actual work of, let's say, like a generalist architect or a traditional architect versus a specialized professional, do you think there's any differences in the day-to-day work from the work of a computational designer versus this more traditionalist architect?
yeah. I mean, absolutely, there's like a big difference. because as an architect, you need to be aware of all the things that go inside your building design and in your whole design process. Whereas a specialist can just focus on one specific field and then be able to assess your design on those aspects. And although the base knowledge that the architects have remains similar to what a specialist would have, and also I think the responsibilities at some level would overlap between an architect and a specialist, but the approach that both of them would take is very different. Starting with as you can see here, the tool sets that a computational designer would use on the softwares that they would use will be completely different. They will depend more on the computational design tools that we have, and then use more of these scripting programming languages versus the traditional way of creating designs in your CAD and BIM softwares, right? And I also feel like the design process is very different. Like for the architects, there's a very linear approach to design, where you start by creating your conceptual sketches, then you go into schematics, and then you jump into your construction drawings, and then you go into your design development stages. But whereas for a computational design, we start by creating this entire workflow where we first try to create an iterative process where you can generate not just one option but multiple options, and then probably be able to also assess those options in terms of the different environmental or structural parameters. And once we have some form, then you can start further developing it in terms of sculpting it or even detailing out the facades and things like that. So I think there's a bit different. Also, the computation as computation designer, I feel we tend to develop this problem solving approach where we don't look at an architecture design as a design project where we can show our creativity, but we also start looking at the design as a problem, and then we start to figure out where we can make this entire design process more efficient by picking out the issues that would create a problem in the future. So I think that ways there is a big difference. Then also, computational tools allow you more flexibility. As I told you, like if you have a small tweak because of XYZ consultant, you can easily make those changes. And as an architect, you have to redo the whole process. Whereas for us, it's just
Yeah.
changing some parameters, and we could get to that outcome. So that kind of really helps.
So basically, you are start working on solutions before the actual design is brought to life.
Yeah, it would be nice if we always look towards design in that way, because
Mm.
if you do this process where you already do an iterative process, and then you already know that this could be the best option, then for an architect to further put down their creativity on that one selected option becomes a more efficient process. So in that way, the computational design could come as a pre-step to the conceptual design stages.
Great. I think that's a huge improvement on the I mean the mindset even that we have, because like you mentioned, we usually
Yeah,
just make a design, we get married to that design, and then well, turns out
yeah,
it doesn't end up like we wanted, and we have to go back, right? But
yeah,
here, as you can mention, we actually working before
yeah,
the design comes to fruition.
yeah,
I think that's a huge improvement on the way that we work.
yeah.
So based on this, like differences on your work, what new challenges have you found by being a computational designer? Like, for example, is there any changes with the way that you work with clients or your coworkers, or even, for example, like the outcomes or outputs and performance of your work? Like, is there any challenges that you have noticed with you being a computational designer?
Yeah, I think as a computational designer, the output that you produce is also different from an architect. So then it has different challenges. For instance, let's say if I talk about building physics knowledge, when I have to do some simulations on a building, then I need to have that specific knowledge before I could, run those analysis, because then I need to get into the details of, how daylight works, what is lux, get into that detailed information. Whereas as an architect, you never really go in depth in that information. And then also, if you, let's say, tomorrow work with a different industry, you have to learn their knowledge base or their skill set. So I think you have to constantly keep adapting your knowledge base. I think that's there is this bit of a learning curve that's always going to be there for computational designers. And second, I feel like now that I've started my own company, I feel there is still some issue with the awareness in the industry. Like people still consider computational design to be, that tool with which you can create these complex forms that look beautiful and inspiring. But they don't know the other possibilities that computational design can offer.
Yeah,
Yeah,
like the
more
awareness from the main public, right? Like I guess that also
exactly.
affects
Yeah,
the I mean, not the relationship itself, but also the expectations of clients, right?
yeah,
Of like
yeah,
what are they thinking you're gonna do with the project, or like what are they? Because I mean, I think we've all happened through that, which is that, for example, in
yeah,
my case, I explained that we are implementing BIM, and they think that
yeah,
we are just like generating the project out of nowhere, something like that, right?
yeah, yeah.
And I guess that also happens with competition design. I don't know, have you had any situation with a client that really didn't understood your
Yeah.
work?
Yeah. So recently I've started working a lot in the furniture industry. And for them being able to digest the thing that computational design can help their industry, because they always look towards furniture designers or these big manufacturing giants who have their own softwares. But computational design can itself be a tool which can fulfill their entire, from design creation to production pipeline. And for them, they don't have this awareness that there are these tools available that can help their process of design. So I think that's where there is this gap between the other allied industries to architecture, which really don't know anything about computational design. And the funny part is, like, I've been doing this for almost 4 to 5 years, and no one in my family is still able to understand what I do. Like, they don't know what computation is. They think I now just make softwares. I'm a software developer. But yeah, there is a very sweet spot between a full-fledged software developer and an architect. So we'll be somewhere there.
Yeah, yeah. Yeah, like I think that's also very typical. Like they think we just install Revit for a living, right? Like
Yeah,
we do that. So yeah, I think that's a very interesting parallel between different specializations. And I mean,
yeah,
I guess as architects, we also have to deal with the clients and have to sell the project, right?
yeah,
But
yeah,
when it comes to the skills that you mentioned, for example, like one of the challenges, of course, is getting updated, getting onto or well, challenge yourself as well to change the skills and the mindset that has to be with computational design. Do you think that what are the skills or the skill set itself that a computational designer should have?
yeah. I think it really depends, like, what do you want to do as a computational designer? Because as I told you, it could be a very vast pool of specialization. But I think to start with, the basic is, we can pick up some visual programming languages, because that's easy for us as architects to transition, because we've been always working with this visual softwares where we can see what's happening with the geometries. So softwares like Grasshopper and Dynamo, they give you a constant feedback of what's happening in your design. Whenever you change something, you can see it live. So I think in that way, it's a very good tool to start with.
Mm,
Uh, Other than that, there's this foundational knowledge that you need. You need to know maths, because you need to create a lot of logics, a lot of equations, algorithms. So it's very important to have a basic knowledge of maths, and also understand how your geometry can be interpreted as data. So I think that's one thing that we as architects are not taught, to start seeing our designs as information. So I think that is one thing that students can start picking up right in their foundational courses. And if you want to, pursue further in this direction, then you can start learning hardcore coding languages like C Sharp, there is Python. So you can, pick up those. And then once you have a good awareness of all the basic tools, then you can, depending on your specialization, you can go into either environmental or building physics analysis. Then you need to learn about the simulation softwares. Or if you're going in structural direction, you need to know their softwares, like we have Tekla and softwares like that. Or you could even go into full-fledged software development. So
So
yeah,
on this topic of like giving the next step, I guess, or the second level on getting specialized in computational design. For example, here we have in the screen, simulation software, structural engineering softwares, web development. What new opportunities do you think that architects can pursue in the field of computational designer? Like once they dive into this field, what do you think are the new opportunities that could be potentially held by architects in this new time and age?
Yeah. Uh, I don't know. Maybe either I'm spoiled by being in Europe, but I don't see like the generalist architects openings or job opportunities that much nowadays, because you need some sort of a specialization with your basic architecture knowledge. And with that, there are these new industries, or like how the tech is developing, there are these new type of requirements that are coming up. So you can actually become an environmental specialist where you're doing all these building analysis and performance analysis. Or you could also go into a structural engineering firm, because they need that connection between an architectural building and how you create your structural designs. You can use these tools to create your basic forms, which I think we've been seeing the most as an architectural designer. There are a lot of these companies which are creating these softwares. Like we have OMRT, we have Giraffe, CBF, and now Autodesk is also creating their own. They have started with this new software called Forma, where you can do the early design iterations. And I think some of the other industries that we tend to ignore are there's 3D printing that's coming up. So they need a lot of these sort of skill sets to automate this whole the workflow that a robot would need, or a 3D printing machine would need. Then we can also look at it as a design process automation. So a lot of these furniture and product companies would want to automate their entire pipeline. And we have some software companies which are giving you those standardized softwares. But these companies have started their creating their own software skill sets where they can create their unique designs. And for that, they need someone who has this specialized knowledge. So yeah, I mean, with computational design, you can go to any industry within this AEC world.
Mm, excellent. Yeah, and I guess also we have to understand as professionals that sometimes these doors aren't opened already, and we have
Yeah,
to forge them, right?
right.
So yeah, I mean, I think this is a huge field that has a lot of opportunities, not only like you mentioned, for example, here in furniture design, but also in software. I mean,
Yeah,
we're seeing a plethora of architects now delving into coding, making these platforms available for the public. So I think
yeah.
when it comes to computational design, it's such a wide field that we haven't yet really adventured so much. So right now,
Yeah, it's more of that solution first and then implementation. So you have to
yeah,
first
yeah,
create a solution for a problem, and then you can find an industry that can use it.
yeah, absolutely. So now talking about this, like opportunities and the potential growth that professionals that delve into specialization computational design can have. What do you
Yeah,
think is the scope for growth in the computational design field? Like, do you think, for example, you mentioned right now about like AI and like 3D printing and all of this stuff. Do you see any emerging trends or
yeah,
advancements in the industry that will impact the future computational design and potentially bring it like a more widespread section or specialization?
yeah, yeah. So, I mean, we have this access to data now. Everything is information, and then once you have access to it, you can actually do a lot of things with it, like doing all these simulations and creating your all these tech. And with this trend coming in, there is this demand for unique softwares. So if you like remember that 10, 20 years ago, like when you or me, like we were like just getting into architecture, we hardly knew about the softwares, a lot of software. We knew like SketchUp, CAD, BIM, BIM also came a bit later. But nowadays, we have so many tools and so many different softwares that you can learn. And every industry is creating their own unique softwares. So I think that demand is going to increase, and we're going to have a lot of softwares that will be developed with all these, AI tools that are coming up. Everyone is creating their own custom software pipelines. So I think that would start happening a lot. And I also foresee like CD would or computational design would become like an integral part where every firm would have one computational department. When I was in Europe, I realized that all of the architecture firms have their own computational design departments now. Which are just doing problem solving in your day-to-day architectural processes, where you could have a complex design built form, you could have some fabrication issues. So all these things can be easily taken up by computational design. So there is a huge scope for growth.
Yes. Also, like when what you mentioned about like each firm having its own department, I think even like we had some previous webinars on the
Yeah,
last months, and I mean I think that's something that we come to know that now firms are actually developing these areas
yeah,
specifically for computational designers or BIM specialists, and I think
yeah,
that's I mean something that we hadn't seen before because like we were mentioning before, like we have this idea of like the architect does basically everything, right? But
yeah,
I think that with the developments with BIM and computational design, it has opened the doors for more collaboration and understanding that, I
yeah,
mean, the same architect cannot do the work of three, four people, right? I mean, of
yeah,
course,
yeah,
I mean, ideally, right? But
yeah,
the now we're seeing much growth and opportunities on this, and I
yeah,
think this is a huge field that I'm really glad that you're sharing your experience on. And part of your experience as well, part of your professional path, has being able to open up your own door when it comes to creating your own company, like forge your own path as well. So I want to know, how did you get the interest in beginning your practice as a consulting company for other firms that might want to get into the world of computational design? Like, what was it that interested you in doing this?
yeah. I think as an architect, I always wanted to have my own firm, but that did not happen. So I thought maybe as a computational designer, I could do that. But after my masters, I got a chance to work in different fields. So I worked with first in a software technology company, then I worked with building physics company. So I saw all these different specializations with using the same set of skill set. So that gave me this understanding that there's a wide application of computational design. There are a lot of still industries that have not yet adopted it, which can quickly do that. And also, there's a big missing skill set that is there. And recently, like India is doing a lot of infrastructure projects. It's growing super fast. And it's very difficult to, suddenly upskill everyone. It's going to take its time. So there is need of these specialized consultations, like we have landscape consultants, structural consultants. Similarly, a computational consultant could, fill in and do all these extra tasks that, you couldn't do with your basic architectural knowledge. And another thing is there is a big need for mass customization because we have so many standard products that everyone wants to create this custom design. And computation just makes this entire customization process super easy and efficient. So I think that's something that I saw. And also there is demand for automation. As I already said, I'm working with a lot of furniture companies where right from design to production to assembly to dispatch, everything could be automated using computational design. So I think all these aspects, forced me or let's say nudged me towards starting my own company where I don't focus on one particular design specialization, but I help everyone as a specialist.
Excellent. So, in your company, in a post 105 technologies, I know that you have different projects that you have delved in before. So, can you tell us a little bit about these projects that we're seeing here on the screen?
Yeah, sure. So this is in fact one of the projects that I did in my initial inception of the company, where we are creating these facades where they wanted to create, just an image, put it on a visual merchandising backdrop, and to be able to manually, cut the circles right so that the image overlaps was very difficult. So with computational design, you can do the design part and also the fabrication part. So I think that entire process helped them create what they were looking for. Then I also work with a lot of landscape companies where, if you have to create a park or if you have to do any analysis for a big site with using these generative design tools, you can create different options, already assess how much shade a park can have, do all the different analysis. and be able to compare your design options and get to a very good design start, right? Again, these softwares, they don't give you the final outcome, they just give you the start as basically of the first canvas where you can further show your creativity. So we won't eat up the jobs of architects, we're just assisting them in the repetitive processes.
Got it.
And the other industry that I focus a lot towards is the furniture design, where I'm also helping them create their unique designs and automating by creating local softwares. So maybe we can quickly show a glimpse of this one, so people understand what do I like intend with this automation thing.
The computational design itself just aids the user, right? It doesn't really solve everything for the architect. It's
Yeah,
just like a tool that we are utilizing. So I think that's something important to remark. And I think, I mean, seeing the video that you showed is a huge improvement on what you or what you were mentioning about the work and the workflow that we can do. I mean,
yeah,
just being able to do this model without actually spending hours and hours modeling it, I think it's a
yeah,
huge development. So
yeah,
now when it comes to the, let's say like this, some of the things that you have observed throughout your career and how, like the clients that you've had and the experiences that you've been in, what do you think is the way that the computational design field is developing on the Indian industry specifically? Do you think that there's still a lot of missing information, or like it lacks awareness on the industry, in India versus, for example, like your experience that you had in Europe? Like, what can you tell us about like what's happening in the Indian market from your perspective?
yeah. I think in India, computational design is still in an early adoption stage, but things are changing. Like we have a lot of specialists that are coming up. So we have these environmental analyst jobs that are there. You need the basic computational design skill set. A lot of people are also developing their own softwares where you can use the specialization of computational design. So the demand is for sure increasing, and it's changing very rapidly. So I think that's the plus thing. But I don't see computational design being limited to just one country or one region, because it becomes more of a software skill set, right?
Yeah,
And as an architect, you need to be there in that region to be able to construct a building. Whereas for computational design, I can be anywhere and assist any other company, because it's just a software dealing that we're doing. So I think in that phase, it also helps us, expand our base not only to India, but help or solve problems for clients all over the world. So I think that's a plus thing. The other problem that I feel in India is right now, because we have, first of all, so many terminologies. We have generative design, parametric, computation. People don't really know which direction to take. They don't understand that it's all part of one umbrella term. So this all get lost in architects who want to create these organic beautiful designs. They feel that only those people need to do computational design, but they never really understand the other aspect of it. So I think that awareness still needs to come, and it's not just limited to India, but I think all the countries are having the same let's say gap.
yeah.
And yeah,
Excellent. So up until this point, we've learned quite a lot about your journey as a computational designer, and also like the observation that you have given us about the skill sets and like the potential opportunities that a computational designer might have. So I want to
yeah,
ask the audience now, do you think that computational designers could be a career in its own, considering everything that we have learned so far? I want to know the opinion of the audience here. And I also want to ask you this, Tarang, like, do you think this is a potential career that we might be seeing in the next few years as an actual discipline that is get taught or is getting taught in like universities, like a career on its own?
yeah. I mean, for sure, like computational design is going to be like a major career, and I feel it's going to become a part of the day-to-day architecture process. So I don't know if it's still going to remain like a specialization, or it's going to become like the generalist approach for solving any design process. But sure, for sure, like you would need these skills a designer or an architect. And I also see like, all the bachelor students nowadays, they're already picking up these tools, even though, the educational system is still not, there to support them. But all these students, they're already, using these tools in their early design learning assignments and everything. So it's gonna pick up and it's gonna be more prevalent. And also like, all the companies are becoming more technology driven, right? We have automation machines for production and everything. So for an architect, it becomes very easy to, create your building, construct your building. So I think there, this skill set would play a major role.
Excellent. Now, just finalizing the session, what actionable advice or tips could you give our audience who are interested in pursuing computational design as a formal specialization or a career itself?
Yeah, it's very difficult for me to give advices, but I think something that I've also adopted is, keep updating the skill set, because you know there's so many tools coming up every day that if you don't learn them, you kind of left behind the learning curve. So we have to stay up to date with whatever new tools we have. It's just gonna make our current design process more efficient. So I think that's very important. Another thing is, as a computational designer, I think we need to find our niche or the specialization that we want to focus on, because there's so many things that we can do. And if you start doing everything, you won't be able to develop your skills at that well. So pick up a niche, be it environmental analysis, structural design, whatever, and then just focus on that. So I think that's something important. Uh, yeah, and I also think like these skill sets or the softwares that we learn, they just enable us. They just make us create solutions. But in the end, we have to actually find problems in the current workflows and then be more proactive in providing solutions. Because I am facing this a lot where I can see a problem in the current workflows in XYZ industry, and then first is you create a solution and then only you can convince them that I can help you make your processes more faster or
Yeah,
efficient. So I think that's where we have to be one step ahead and find these things. And yeah, one last thing would be to keep this problem solving approach rather than just designing, because as designers we just get stuck, as you said, in the design. We start connecting with it more, and then we forget about everything else. So I think we have to keep evolving the design, not only in the creative aspects of it, but also the other processes. So it's good to always, keep this problem solving approach towards design.
excellent. Well, thank you so much for sharing that, Tarang. I think
Yeah.
the people in the audience will be finding this very helpful and very insightful on what to do next if they are interested in choosing computational design. And before we move on to the Q&A, I would just like to remind the audience that the next episode, which will be the end of this series, we're going to be talking about how to land your dream job at a top architecture firm in the world. We're going to have a very interesting discussion about networking, finding jobs, developing your own skills, and more related topics. And also, I would like to remind you that you can win while you learn. This series contest that we are running, you can go ahead and look at the leader scores on our social media. So finally, I want to open up the Q&A for some questions that have been asked by the audience. So let me just go ahead and open up the panel here. There we go.
Arat, I'm really interested in knowing the answer for the last poll question. I want to see like how the audience is thinking.
Yeah. We're gonna share the responses with you, so you can see also
Okay,
like
great.
what do the people think, right? So
Nice. Yeah.
let's go ahead and pick some of the questions. Let me go and see them. Uh, um, from Akshada. Let me go and see some questions. There you go. Oops, a little bit too small. Uh, so we have a question from Aryan. What is the potential for a recent graduate or fresher architect working in the domain of BIM at one of the top firms? but with an interest in computational design. So it's a quite like a long question. So I guess there's going to be two parts to it. The second part would be, what key points would you say are crucial to switch from BIM to computational design, both from the perspective of gaining the knowledge, mastering the skill, and career switch? So I guess we can respond to it and like the what is the potential, or like what is the usage for maybe like a fresher architect working in BIM, or like the potential of computational design for them, I guess, and what would be the main skills that somebody would need in order to switch from BIM to computational design.
Yeah. I think Arat, you can also help me answer this because you yourself are a BIM specialist. But maybe I can like start with a point where as I said, computational design is more like a collaborative tool, and there are also opportunities for you to do computational design within the BIM environment. There are tools like Dynamo that are within Revit that you can use to automate your existing BIM workflows.
Mhm.
And also, there are a lot of these new tools coming up, like the Rhino Inside, where you can do this, collaboration between a design software like Rhino and a more BIM software like Revit. So I think all those possibilities are there if you want to, stick to the BIM side of things and then still be able to do computational design as a career.
Yeah. Also, I would like to add for this, like currently with BIM, I mean, there is a lot of applications of computational design already, or like computation design related tools. Like for
Yeah,
example, with naming conventions, you can make a script in Dynamo or like even Python and allow, like the naming convention to happen across many files and many information containers, we call it. So I mean,
yeah,
I think that the application is already there. We just have to like look a little bit more to like, I mean, I guess the first door would be Dynamo, which is already included within Revit. Get a little
yeah,
bit more acquainted with it, how it works, like the scripting, and like we have mentioned with Tarang, like the understanding the mindset necessary for the data, and like understanding that we're creating solutions, right? Instead
yeah,
of like the design. Well, like we mentioned before, we're not creating the design itself. We're just
yeah.
aiding the production with these tools.
Right, right. Right, and BIM is already a very data heavy environment. So I think
Mhm,
that should make it even more easy to, pick out the loopholes and just, make those processes efficient.
yes. So let me go with another question from um, there we go with Isha. Um, I lost it. There we go. So how do you choose your field of specialization for masters, like based on what? Your interests or positives, or like what's going on to be good or trendy for the future?
Yeah, personally, I didn't go for the latter approach. I, first went and practiced as an architect, and I really tried to understand the industry first. And once I knew, what kind of specialization I wanted to focus on, then I went and did a master's. So I think it's also important for you to, first understand the possibilities or the opportunities that we have, and then be
Mhm.
able to pick up a specialization. And even before doing any masters, there's so much information available on the web that we can get a good understanding of what that specialization would offer, and if we would be interested in doing that particular specialization. So I think first hand would be to first look for your interests or your career direction.
Mhm. Excellent. Now let's go with a question. Let me go with let me pick some. What actually will be taught in computation? I mean, I guess they're referring to the computational design course. What actually
Okay.
will be taught in CD is just the softwares and implementation, without
Uh,
spoiling too much, right? Of course.
so I don't know if like this question is in general in computational design courses, or is it like particularly to innovator course?
I mean, I think you can share like for your section, like what you're in charge of and the course, like what specifically can they expect to see from you, to learn from you in this course?
Yeah. So I think what Novator is doing, or what any masters would do, is give you a general perspective of how computational design can be applied to all the industries. So right from teaching the basic foundations, you
Mhm.
start with Grasshopper, or even first-hand understanding of how Rhino works, how data works, and then going
Yes.
into Grasshopper, learning the basics, learning the foundation, and then keep developing different set of skill sets, be it structural analysis, building physics, or even going into the web development direction. All the masters
Yes.
and these specialization courses, they can only like show you everything, and then I think it's upon you to further develop this further.
Yes. Also, if you want more information, a counselor from Novator can reach out to you and give you more information about the course itself. So if you're interested in that, you can also reach out to us through social media. And let's go with a question from Elisa. How can you convince people to use computational design tools? Architects and engineers are usually afraid of it, that or are usually afraid to going to replace them. That's a very interesting question.
Yeah, I think that's a very big challenge. I mean, first of all, I think we architects are always, fearful in adapting to new technology. So we
Mm.
kind of very set in the predefined workflows that we have. So I think it becomes a big challenge for us to, first convince them that, we are just making your process easier. We're there to assist your process and not replace it. So I think that's one resistance that these architects and all the engineers have. So I think first we have to be more clear in explaining what these tools can do. Because as architects or as computational designers, we focus on the software part. But I think what's also
Yes.
important is being able to convey what this particular tool or the software can do to you or to your workflows. So I think that
Yes.
skill set is something that we also have to learn.
Excellent. So let's go with another one. Let's go with one from Abhishek. So someone who is in their initial stage of their career, what is more important? Learning tools and software or learning about traditional detailing, documentation, site knowledge? Are they two different career roles?
Yeah, two different career roles for sure. But I think it's also good to have a general idea about both the fields, be it computation skills or because as an architect, if you're going more towards documentation and BIM side of things, you also need to understand what kind of possibilities computation can offer you. And if you're on the other side, you need to you can, by knowing just the basics of documentation and construction drawings, you can actually be able to create tools for them to adopt. So I think it's good to have a general knowledge about the other field, but yeah, focus on that direction.
Excellent. Now let's go and take some, let's do another question because we have plenty of questions. The audience seems to be very interested on the
Okay,
topic.
that's
So let me just open up the panel again because it kind of gets lost. It doesn't want to get open. So let's go with a question from Ayesha. Let me locate it. Um, Ayesha, where are you? Uh, oops. Mm, there we go. So let's go with Ayush, not Ayesha, sorry. I am an architect currently pursuing construction management. I am mostly focusing on the technology bit of construction, working with BIM and Rhino too. Do you think after a CM degree, is it still possible to work with architectural design practices?
um, yeah. I think he's talking about construction management as a
Yeah,
degree.
construction management,
So
yes.
yeah, I think it's possible to work with architectural firms because nowadays this entire process has become very collaborative, and all the architecture firms are rooting towards these specialists. So even if you have a specialization in construction management, I think this could still be a skill set required by architecture firms.
Mm.
I hope I am able to answer that, Arad.
Yeah, I think that's a very straightforward answer.
Yeah.
Let's go with a question with Elisa. How steep is the learning curve to become a computational designer if you only have traditional architectural knowledge?
Uh, I think it's not steep, but it's
Hmm.
a constant curve. So like you can start with gradual learning and then keep updating your skills. You don't have to learn the most advanced tool set. You always have to start with the basics. So it's not very steep, but I think it's a very long curve and a continuous one.
Yeah, I think it's more like we mentioned about like the mindset, right? Like, I mean, we can learn pretty much any software, but understanding that the mindset required for these tools is a little bit different than we are already used to. So yeah, I would just like to add, for example, from my perspective as a BIM specialist, people often tend to use Revit, for example, the same way that they want to use AutoCAD, right? And it's not the
Yeah,
case. Like it's not going to work the same. So I
yeah,
think the first step would be to change the mindset,
yeah,
and thus like the gap on the or the steepness of the learning curve would be much easier to handle.
yeah. I think
Um,
it's a very good point because while I'm teaching, a lot of students have this thing that whatever they do in Rhino, they want to
mm,
do that same step in Grasshopper, but they tend to not focus on the additional benefits or the possibilities that these tools can offer.
mm,
So I think like with a new tool, you also get new sort of outcome. So I think you also have to adapt to them.
yes. So there's a question from Eleazar Coelho. What do you recommend to start understanding CD using platforms? Or I guess platforms that are like closed source or open source.
Uh, can you repeat that question, please?
Yeah, like what do you recommend to start understanding computational design using platforms? I guess what they're referring to is like starting to maybe use open source software, like for example Dynamo or like Blender or whatever, or like you actually have to like go into like this more closed source or like I guess like a training specifically meant for that. What would you recommend for that, like in this specific scenario?
Yeah, I think again, it depends on the problem that you want to solve. So if there is a particular software required for solving X problem, you need to go in that direction. And but on the brighter side, I think all these softwares can provide solutions. So you can probably start with those open-ended or free softwares, and then jump into getting into the paid one if it's really needed.
Excellent. Let's do another one. What are some of the degrees that will help getting a specialization in in-depth knowledge and skill set required in the field of computational design and parametric architecture?
Mm. I mean,
I mean, I
there are
guess
a lot of,
itself, architecture, I mean, itself already has like the basis
yeah,
to have that. But I mean, also there's this company called Novator, so maybe you should check it out as well.
yeah,
I mean, yeah, you can check the this website so you can have a little bit more information. And if you are interested to learn more about the course, you can also reach out. And people from our board of mentors and our board of counselors will also be happy to help you understand a little bit more. But I guess in this case, like we were mentioning, architecture itself already has the basis to understand like this, because at the end of the day, it's still based on construction, right? Like we're not understanding like making the fire, right? But like we had mentioned in the previous question, I guess the mindset, like we were mentioning or previously, is what needs to be adapted, right?
yeah.
Um,
Yeah, I
uh,
think I would like, it's not right to talk much about Novita itself, but I think it's It's also good to look at these courses. I'm not talking just about Innovator, but there are a lot of courses who offer you a short-term specialization course focusing
Mhm.
on one or two specialization, because usually these degrees they focus on everything and it tends to become too long. So I
Mhm.
think you can also route towards these specialized courses short term and then being able to adapt. Yeah.
Yes. Let me just do like a last question. There was one pertaining AI, so let me just try to find it because there's a lot of questions. Um, so, mm, mm, well, I cannot find it. I just saw it right now, but I mean, it's getting lost on the plethora of questions. But I guess we can reframe it. The question that they were asking, like, do you think there is a possibility for computational design to implement and make usage of this like booming sector of artificial intelligence that we have seen on the last few years? Like, do you think there's could
Yeah.
be like a potential implementation of AI in computational design, or even like in general in architecture?
Yeah. I mean, I think AI is the tools that we have. They're kind of it's very easy to use these tools in all platforms, and I think already in computational design, a lot of places where these tools have already been used and being implemented. Uh,
Mhm.
a lot of these big companies are working towards using them as their base to either improve their rendering processes using Midjourney and processes like that, or with also using these tools like ChatGPT and things like that. You can also create Grasshopper scripts directly, or
Yeah.
even use their help to create a very well defined or a well structured Python code or a C# code. You know, you can always already start using these to improve your codes.
Yeah, yeah, absolutely. And if you're also interested in checking more a little bit more on how AI is being implemented in architecture, we had made another webinar previously with Sahej Bhatia, which is also a specialist that is joining on in the Master's Computational Design course, where he talks about his experience using AI tools in order to advance his workflow with design itself. So yeah, that's
Yeah.
pretty much it. I think that we have some pretty interesting questions. The ones that we didn't get to answer in the live session will be responded later by our specialist as well, so that none of the questions get unanswered. So once again, thank you so much, Tarang, for joining us today. I think it was a very insightful session. I think everybody will be benefited greatly from your experience and all the observations and points you had to share. So, is there any parting words that you would like to add before we finish the session?
Yeah, I mean, thank you so much, first of all, for having me. And I'm glad I was able to, share my learnings and probably help the new upcoming students and architects to, take computation design as a full-fledged career in itself. Because I am seeing the benefits of it already. So I'm sure, like, once people start adopting to these tools, they will also, enjoy the fruits of it. So yeah, I think good luck to everyone, and I hope we have more computational designers in the future than being specialists or architects. So yeah,
Yes. Excellent. Well, thank you so much once again, Tarang, for joining us. It was very, very fruitful conversation. And also thank everybody for joining us in this fourth webinar. I am going to remember you once again that on the end of this month, actually, we're going to have the final episode. And later then, we're going to pick the winners for this contest. So thank you once, all of you, for joining us. And we'll see each other on the next one. See ya.
amazing. All right, bye everyone.
Bye, Tarang.